The issue involves THHN wire failing in a bakery due to heat and moisture exposure from ovens and water ingress into the conduit. The THHN wire is bubbling and turning white, indicating thermal degradation. XHHW-2 wire is a viable solution due to its temperature and moisture resistance. XHHW-2 wire is rated for continuous operation at temperatures up to 90 degrees Celsius or 194 degrees Fahrenheit. This temperature rating is suitable for bakery oven environments. XHHW-2 wire possesses moisture-resistant insulation capable of withstanding water and steam exposure. During installation, ensure the XHHW-2 wire is protected from physical damage. Use appropriate conduit fittings and watertight connections to prevent water from entering the system. Heat-resistant conduit can offer further protection to the wire from oven heat. Consider repiping as an alternative solution. Repiping offers a permanent solution but involves significant cost and downtime. Silicone rubber cable represents another option. Silicone rubber cable exhibits high temperature and water resistance. However, it's more expensive and might have limited availability. Check the oven manufacturer's specifications to verify the selected wire meets the oven's recommended operating temperature. Utilize a ground fault circuit interrupter, or GFCI, to safeguard the circuit against electrical faults caused by moisture damage. Implement regular inspections and maintenance of the electrical system to proactively prevent similar issues in the future. Additional points to consider: firstly, thoroughly assess the environmental conditions surrounding the electrical installation. This includes measuring the ambient temperature near the ovens, evaluating the level of moisture present, and identifying any other potential factors that could contribute to wire degradation. Secondly, when selecting a wire type, carefully review the temperature and moisture resistance ratings to ensure they align with the specific environmental conditions. Consult the National Electrical Code, or NEC, for guidance on wire selection and installation requirements in damp or wet locations. Thirdly, proper conduit installation is crucial to prevent water ingress and protect the wires from physical damage. Ensure that all conduit connections are watertight and that the conduit is adequately supported to prevent sagging or displacement. Fourthly, consider the use of heat-resistant conduit materials, such as rigid metal conduit or intermediate metal conduit, to provide additional protection against oven heat. These materials can withstand higher temperatures compared to PVC conduit. Fifthly, ground fault circuit interrupters, or GFCIs, are essential for protecting circuits in damp or wet locations. They detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shocks and minimizing equipment damage. Sixthly, regular inspections and maintenance are vital for identifying and addressing potential problems before they escalate. Schedule periodic inspections of the electrical system to check for signs of wire degradation, loose connections, or water ingress. Seventhly, document all inspections, maintenance activities, and repairs performed on the electrical system. This documentation can be helpful for tracking trends, identifying recurring problems, and demonstrating compliance with safety regulations. Eighthly, if repiping is necessary, carefully plan the new conduit route to minimize exposure to heat and moisture. Consider rerouting the conduit away from the ovens or using a different type of conduit that provides better protection. Ninthly, when using silicone rubber cable, ensure that it is properly sized for the circuit load and that it is installed in accordance with the manufacturer's recommendations. Silicone rubber cable is more flexible than other types of wire, so it may require additional support to prevent sagging or kinking. Tenthly, consider using a thermal barrier to shield the conduit and wires from direct heat from the oven. This barrier could be made of a heat-resistant material such as mineral wool or ceramic fiber. 11thly, if water ingress is a persistent problem, investigate the source of the water and take steps to eliminate it. This may involve repairing leaks, improving drainage, or installing a waterproof barrier. 12thly, when selecting conduit fittings, choose fittings that are specifically designed for wet locations. These fittings have features such as watertight seals and corrosion-resistant materials to prevent water ingress and ensure long-term reliability. 13thly, consider using a cable tray system to support the wires and conduit. Cable trays provide a secure and organized way to route electrical cables, and they can also help to protect the wires from physical damage. 14thly, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the National Electrical Code, or NEC, and other applicable safety regulations. 15thly, provide adequate ventilation in the bakery to help dissipate heat and reduce moisture levels. This can be achieved by installing exhaust fans or opening windows. 16thly, if the oven manufacturer recommends specific wire types or installation practices, follow those recommendations carefully. The manufacturer's recommendations are based on their expertise and knowledge of the equipment. 17thly, consider using a wire with a higher insulation rating than XHHW-2. For example, RHW-2 wire has a similar temperature rating to XHHW-2 but has a thicker insulation layer, which may provide better protection against moisture. 18thly, if the problem persists despite your best efforts, consult with a qualified electrical engineer to develop a comprehensive solution. An engineer can perform a detailed analysis of the electrical system and recommend the most appropriate course of action. 19thly, remember that electrical safety is paramount. Always de-energize the circuit before working on any electrical equipment, and follow all applicable safety procedures. 20thly, document the wire size, type, and insulation rating used for each circuit. This information will be helpful for future maintenance and troubleshooting. 21stly, consider using a surge protector to protect the electrical equipment from voltage spikes and surges. Surge protectors can help to prevent damage to sensitive electronic components and extend the life of the equipment. 22ndly, install signage to warn personnel about the potential hazards of working near electrical equipment. The signage should clearly identify the voltage and amperage of the circuits and provide instructions on how to safely operate the equipment. 23rdly, provide regular training to personnel on electrical safety procedures. The training should cover topics such as lockout/tagout procedures, personal protective equipment, and emergency response. 24thly, ensure that all electrical equipment is properly grounded to prevent electrical shocks. The grounding system should be tested regularly to ensure that it is functioning properly. 25thly, consider using a thermal imaging camera to inspect the electrical system for hotspots. Hotspots can indicate loose connections, overloaded circuits, or other potential problems. 26thly, if you are unsure about any aspect of the electrical system, consult with a qualified electrician or electrical engineer. It is always better to err on the side of caution when dealing with electricity. 27thly, remember that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any changes to your electrical system. The National Electrical Code, or NEC, specifies requirements for electrical installations in various environments, including those with high temperatures and moisture. Article 310.15 and its associated tables provide ampacity ratings for conductors based on insulation type and temperature. Table 310.15b16 is commonly used to determine the allowable ampacity of conductors and raceways or cables based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. However, for environments with higher ambient temperatures, correction factors must be applied to the ampacity ratings. Table 310.15b2 provides temperature correction factors for conductors with different insulation temperature ratings. For example, if the ambient temperature is 50 degrees Celsius or 122 degrees Fahrenheit, a correction factor of 0.82 may need to be applied to the ampacity of a conductor with a 90 degrees Celsius insulation rating. In addition to temperature correction factors, dirting factors may also need to be applied if multiple conductors are installed in a raceway or cable. Table 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. For example, if there are 4 to 6 current-carrying conductors in a raceway, the ampacity of each conductor must be reduced by 80%. Article 314 covers requirements for outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. It specifies the minimum size requirements for boxes based on the number and size of conductors entering the box. Article 350 covers requirements for flexible metal conduit or FMC and liquid-tight flexible metal conduit or LFMC. It specifies the permitted uses, installation requirements, and support requirements for these types of conduit. Article 356 covers requirements for liquid-tight flexible non-metallic conduit or LFNMC. It specifies the permitted uses, installation requirements, and support requirements for this type of conduit. Article 430 covers requirements for motors, motor circuits, and motor controllers. It specifies the overload protection requirements for motors, including the selection of overcurrent devices and thermal overload relays. Article 440 covers requirements for air conditioning and refrigeration equipment. It specifies the branch circuit conductor sizing requirements, overcurrent protection requirements, and disconnecting means requirements for this type of equipment. It's recommended to consult the latest edition of the National Electrical Code, or NEC, for the most up-to-date requirements. Proper wire selection involves considering the specific operating conditions, including temperature, moisture, and chemical exposure. Additionally, proper installation techniques and regular maintenance are crucial for ensuring the long-term reliability and safety of electrical systems in challenging environments like bakeries. The choice of wiring method and material should be based on a thorough evaluation of the environmental conditions and the specific requirements of the application. It is always advisable to consult with a qualified electrical engineer or electrician to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. In addition to the factors already mentioned, it is also important to consider the voltage drop in the circuit. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code, or NEC, recommends that the voltage drop in a branch circuit should not exceed 3% at the farthest outlet. To minimize voltage drop, it is important to select conductors with an appropriate size and length. Larger conductors have lower resistance, which reduces voltage drop. Shorter conductor lengths also reduce voltage drop. It is also important to ensure that all connections are clean and tight. Loose or corroded connections can increase resistance and contribute to voltage drop. The use of copper conductors is generally preferred over aluminum conductors, as copper has a lower resistance. However, aluminum conductors can be used if they are properly sized and installed. When using aluminum conductors, it is important to use connectors that are specifically designed for aluminum wire. These connectors are typically coated with an antioxidant compound that helps to prevent corrosion. It is also important to follow the manufacturer's instructions when installing aluminum wire connectors. Over-tightening or under-tightening the connectors can damage the wire or the connector, which can lead to loose connections and increased resistance. In addition to voltage drop, it is also important to consider the ampacity of the conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. The National Electrical Code, or NEC, provides tables that list the ampacity of conductors based on these factors. It is important to select conductors with an ampacity that is sufficient to carry the load of the circuit. Overloading a conductor can cause it to overheat, which can lead to insulation damage and fire. When selecting conductors, it is also important to consider the type of equipment that will be connected to the circuit. Some types of equipment, such as motors, require conductors with a higher ampacity than other types of equipment. The National Electrical Code, or NEC, provides specific requirements for the sizing of conductors for motor circuits. It is also important to consider the environment in which the conductors will be installed. In wet or corrosive environments, it is important to use conductors with insulation that is resistant to moisture and chemicals. The National Electrical Code, or NEC, provides specific requirements for the installation of conductors in these types of environments. Finally, it is important to remember that electrical work can be dangerous. It is important to follow all applicable safety procedures and to wear appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. When dealing with electrical systems in a commercial bakery setting, several factors require meticulous attention to ensure safety, reliability, and compliance with electrical codes. Firstly, understanding the specific electrical demands of the bakery equipment is paramount. Ovens, mixers, proofers, and other appliances often have varying voltage, amperage, and power requirements. A comprehensive load calculation should be performed to determine the total electrical load of the bakery. Secondly, the choice of wiring methods and materials is crucial in the harsh environment of a bakery. High temperatures, moisture, and the presence of corrosive substances can significantly impact the lifespan and performance of electrical components. Therefore, selecting appropriate conduit types, wire insulation, and junction boxes is essential. Thirdly, grounding and bonding are critical for electrical safety. A properly grounded electrical system provides a low impedance path for fault currents, minimizing the risk of electric shock and equipment damage. All metallic equipment, including conduit, enclosures, and appliance frames, should be properly bonded together and connected to the grounding electrode system. Fourthly, overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Selecting the correct size and type of overcurrent protection devices is essential for preventing equipment damage and electrical fires. Fifthly, GFCI protection is required in certain areas of a bakery, such as near sinks and other wet locations. GFCIs detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shocks. Sixthly, regular maintenance and inspection are crucial for identifying and addressing potential electrical problems before they escalate. A qualified electrician should conduct periodic inspections of the electrical system, checking for loose connections, damaged wiring, and other signs of wear and tear. Seventhly, compliance with applicable electrical codes and standards is mandatory. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, and local jurisdictions may have additional requirements. It is essential to be familiar with and adhere to all applicable codes and standards to ensure a safe and compliant electrical system. Eighthly, employee training on electrical safety is essential. Bakery staff should be trained on the proper use of electrical equipment, the hazards of electricity, and the procedures to follow in case of an electrical emergency. Ninthly, proper labeling of electrical panels and circuits is important for easy identification and troubleshooting. Clear and accurate labeling can save time and prevent mistakes during maintenance and repair activities. Tenthly, surge protection can help protect sensitive electronic equipment from voltage spikes and surges. Surge protectors should be installed at the main electrical panel and at individual equipment locations. 11thly, the use of energy-efficient lighting and equipment can help reduce energy consumption and lower operating costs. LED lighting and energy-efficient appliances can significantly reduce the electrical load of the bakery. 12thly, proper ventilation is important for removing heat and moisture from the bakery. Adequate ventilation can help prolong the life of electrical equipment and improve the overall working environment. 13thly, the use of corrosion-resistant materials is essential in areas where electrical components are exposed to corrosive substances. Stainless steel conduit and enclosures can provide excellent protection against corrosion. 14thly, the proper selection and installation of electrical equipment can significantly reduce the risk of electrical hazards. This includes using properly rated cords and plugs, ensuring that equipment is properly grounded, and avoiding the use of extension cords as permanent wiring. 15thly, the establishment and implementation of a comprehensive electrical safety program is crucial for maintaining a safe and reliable electrical system in a commercial bakery. This program should include written procedures, regular training, and periodic inspections. 16thly, the consideration of future electrical needs is important when designing or modifying the electrical system. Planning for future expansion or changes in equipment can help avoid costly and disruptive upgrades later on. 17thly, the proper disposal of electrical waste is essential for protecting the environment. Fluorescent lamps, batteries, and other electronic waste should be disposed of in accordance with applicable regulations. 18thly, the use of a qualified electrical contractor is essential for ensuring that electrical work is performed safely and correctly. A qualified contractor will have the necessary expertise and experience to handle all aspects of the electrical system, from design and installation to maintenance and repair.